Hi, everyone. Have you ever noticed that even when it's 70 degrees Fahrenheit outside, your body temperature is still somewhere between 98 and 99 degrees? Or that after you eat a candy bar, your blood sugar doesn't go through the roof? Well, that's because of a process in our bodies called homeostasis. Let's take a look at what homeostasis is and how it works. In order to maintain optimal health, there are a lot of conditions inside our bodies that must remain within certain levels. Examples of these internal conditions are body temperature, blood pressure, and respiratory rate. Not to mention blood levels of gases, electrolytes, nutrients, hormones, and other substances. When any of these get out of the normal range, our bodies may not function properly. For example, glucose is the main simple sugar we use to provide our cells with the energy they need to do their work. Most glucose in our bodies is stored as a molecule called glycogen, but the most readily available supply is floating through our bloodstream. Some people call this blood sugar, but since there are multiple kinds of sugars, it's more accurately called blood glucose. Before eating, blood glucose should be between 70 and 99 milligrams per deciliter of blood. That's considered the normal range, and we typically fluctuate within that range throughout the day, based on our meals. If your blood glucose level falls below 70 milligrams per deciliter, it's considered hypoglycemia. The prefix hypo means low, glyce refers to glucose, and the suffix emia means in the blood. Since our brain cells don't store any glucose, you may experience symptoms like dizziness, lightheadedness, and headaches. If it gets really low, you could lose consciousness. If the blood glucose levels are consistently high, that's called hyperglycemia. Hyper meaning high. Symptoms of hyperglycemia include frequent urination, excessive thirst, and glucose in the urine, which should never happen under normal circumstances. The long-term effects could result in nerve damage, vision loss, and organ failure. So it's in our best interest to have mechanisms in place that maintain our blood glucose levels within that normal range. This is one example of what homeostasis does. It's a dynamic process that is constantly tweaking the levels of controlled conditions as they fluctuate within their normal ranges, typically around an individual set point. When homeostatic mechanisms fail to maintain the levels of one or more controlled conditions, that's when we drift outside of optimal health and into disease state. When it comes to glucose, diabetes mellitus is one of those diseases. The main mechanism that homeostasis uses to maintain controlled conditions is negative feedback. Let's stick with blood glucose as our example. Negative feedback means the level that was detected in a particular controlled condition is reversed. So if blood glucose is high, the mechanism results in making it lower. If it's low, we make it higher. The word negative simply means reversing the original detected condition. When blood glucose levels are high, cells in the pancreas detect that level and in response, release a hormone called insulin into the bloodstream. Hormones are chemical messengers that the body produces that usually use the bloodstream to get to the cells and tissues they're targeting. That insulin stimulates cells, especially in the liver and skeletal muscles, to take the glucose in the blood and absorb it, therefore lowering the levels of glucose in the blood. So the high level of blood glucose is reversed by this homeostatic mechanism. That's a negative feedback loop. If the levels get too low, the pancreas releases a hormone called glucagon that does the opposite and raises the blood glucose. That's also a negative feedback loop. Even though the levels went up, it's the reversal that makes it negative. Okay, so that's homeostasis and negative feedback in a nutshell. Good luck, and I'll see you next time.